Alright, so this is problem 3 of the exam. Problem 3 reads, the graph of f of x equals 3x squared minus x, all that divided by x squared plus 2, crosses its horizontal asymptote at what x value? Okay, so what we need to do here is we need to recall horizontal asymptote, how we find horizontal asymptotes. Okay, so what I wrote down here, finding horizontal asymptotes. Given a function f of x, for example, like this function f of x, in order to find the horizontal asymptotes, we need to see how the graph, or how the function behaves as x approaches infinity, and how it behaves as x approaches negative infinity. Alright, so that's what I'm going to go ahead and do. I'm going to go ahead and take the limit as x approaches infinity of this function here. Alright, so if we want to see how this behaves as x approaches infinity, we want to go ahead and solve this and find out what is the limit. Okay, so if I plug infinity, I'm going to get infinity divided by infinity. That's indeterminate. Okay, so what I have to do here. Alright, let's see. We usually look at the denominator and we see what is the highest degree. It's 2, so we have an x squared. So what I want to do is I want to multiply the numerator by the reciprocal of that, and the denominator by the reciprocal of that. Okay, so if we do that, go ahead and distribute this to each term. We get the limit as x approaches infinity of 3x squared divided by x squared minus x divided by x squared. All that divided by x squared divided by x squared plus 2 divided by x squared. Okay, so what happens now? That cancels out, one of these cancel out, and that stays the same. So now we have the limit as x approaches infinity of 3 minus 1 over x, all that divided by 1 plus 2 divided by x squared. Okay, that's good. We can go ahead and plug in infinity now. So we plug in infinity, we get, so that's equal to 3 minus 1 divided by infinity divided by 1 plus 2 divided by infinity. Okay, but we know that 1 divided by infinity is 0, so that's 0. And we know 2 divided by infinity, that's also 0. So we're left with 3 over 1, therefore we're left with 3. So one of the horizontal asymptotes is, so it's minus y equals 3. Alright, so we did the limit as x approaches infinity, now we have to do the limit as x approaches negative infinity. Alright, so it's going to be very similar. As x approaches negative infinity of this function, I'm going to do the same trick. So I'm just going to go ahead and write down what I have if I do that trick. So we have 3 minus 1 over x divided by 1 plus 2 divided by x squared. Okay, so now I go ahead and plug in negative infinity. So I get 3 minus 1 over negative infinity divided by 1 plus 2 over infinity squared. Okay, so 1 divided by negative infinity, that's 0 as well. 3 minus 0 is still 3. And then we have infinity squared, that's just a very big number. 2 divided by another very big number, that's 0 as well. So that's just 1. And that is 3. So that implies y equals 3. So it looks like there's only just one horizontal asymptote, that's y equals 3, because we got y equals 3 as the limit goes to positive infinity, and we got y equals 3 as the limit goes to negative infinity. So the only horizontal asymptote we have is y equals 3. Alright, good. Now we want to find the x value that crosses right at y equals 3. So we want to find the x value that produces y equals 3. So because if we find that x value that produces y equals 3, then we know the graph crosses at that point. Okay, so let's erase this right here. Need some more work. I'm just going to write down, we already know the horizontal asymptote. No, horizontal asymptote is y equals 3. So just that we need to know. Okay. Alright, so in order to find the x value that produces y equals 3, we need to make this function equal to 3. So 3x squared minus x divided by x squared plus 2 is equal to 3. So you want to find an x value that gives y 3. Okay, so what I'm going to do is I'm going to move the 3 to the other side, or to the left side. So I'm going to get 3x squared minus x divided by squared divided by x squared plus 2 minus 3 over 1. Okay, so now I want to, and that's equal to 0. Let's erase this one. That's equal to 0. So now move the 3 to the other side. Okay, so now I want to combine these two fractions. In order to combine these two fractions, we need the LCD. So go ahead and, so the LCD is x squared plus 2, right? So we have x squared plus 2 in the denominator. And we have 3x squared minus x minus, since we know that x squared plus 2 is the LCD, we got to multiply 3 by x squared plus 2. So that's 3x squared plus 2. Alright, so now that equals 0. Alright, so let's go ahead and distribute here. Distribute the minus 3 to both of these terms. So we have 3. So now we have 3x squared minus x minus 3x squared minus 6. And that's all divided by x squared plus 2. And that's equal to 0. Okay, let's go ahead and simplify this. 3x squared cancels with 3x squared. We're left with minus x minus 6. So minus x minus 6 divided by x squared plus 2, and that's equal to 0. Okay, so the only time that a rational expression is equal to 0 is when the numerator is equal to 0. So what we have to do is forget about the denominator here, just look at the numerator and equate that to 0. So alright, so if we solve this linear equation here, we'll find the x value. So we have that minus x equals 6. Divide both sides by negative 1 or multiply both sides by negative. Then that implies that x is equal to negative 6. So therefore at x equals negative 6, the graph will have a point 3, therefore it will cross. So therefore the point negative 6, 3 exists on this graph and it crosses right at that x value, negative 6. Alright, so little recap. We want to find the x value that crossed the horizontal asymptote. First we need to find the horizontal asymptote, but remember, to find the horizontal asymptote we need to take the limit as x approaches infinity and as x approaches negative infinity of that function. And that's the function. I took the limit as it went to infinity, and I took the limit as it went to negative infinity, and I obtained that the only horizontal asymptote was y equals 3. Once we have that fact, we go ahead and we want to find that x value that crosses at y equals 3. So we want to equate the function to 3 to find out what x value produces a y value of 3, and that means it will cross. So we did that, equated it to 3, solved this, and we got x equals negative 6.